Hello, everybody. This is the primer for Lab 6. It comes with 5 files. I've already got them up and downloaded here. So you'll have to do that first. The main thing this lab's going to be going over is you're going to be working a little bit with a Java GUI. Nothing too crazy with it, though, as well as doing some math with this small integer class. You're going to be filling out the math portions of this small int class. So I already got the 5 files here. The 2 that you're going to be working on is going to be the main GUI launcher. We have some to-dos here, as well as, of course, the small int.java. Everything is commented, but you will have to fill out these 1, 2, 3, 4, 5 methods. Just as it's commented, and these 4 are going to be very similar. And then for the main GUI launcher, all you're going to do is you're going to fill out this one, and you have just a little bit to do here. So here we see an example of what we want to be outputted to the console. The idea of the program is we're taking one number from the user, and then we take the second number from the user, and then we would do a little bit of those math operations that we would fill out here, and these would get printed to the screen. And here's an example of one of those. See, we have the sum of 2 of these small integers, and then we're just going to be printing that to the GUI instead of the console. Moving back to the small int, the idea of a small integer is maybe not necessarily that it's actually small, but just that it's a more safe integer. And what I mean by that is normally when you have an integer, there's a fixed size that any data type in any programming language can take up. Well, I suppose I should say in Java can take up. In the case of an integer, you can, if you want to Google the max integer, there's a max and there's a minimum. It's a very large positive number and a very large negative number. If any number tries to go over that, it's going to do what we call overflow, and it will basically wrap or back around and go to the negative side. So if it gets really, really, really large, like very positive, at some point it'll go negative again. And same thing happens in the other direction. So if you have a very, very small negative number, and then it gets too negative, it'll wrap back around positive. So the small int, this class is, when I say it's a safer integer, is we can actually try to test if it will go over or under that maximum, because otherwise we may never know. So looking at some of these methods, the constructor, we can see it takes in a long as a value, and that's not an integer, that's a long. That's going to be larger than an integer, so it will take up, it'll be able to hold more numbers. The maximum number is going to be larger than the maximum int. So the first thing we can do with this long, because it's bigger than an integer, we can actually check if it's bigger than the max value, or the max value and the min value of an integer. So this min value, remember, is a very large negative number, and the max value is a very large positive number. Because we have a long coming into this constructor, we're able to verify that if it's smaller than this number or if it's bigger than this number. Because if this was an integer, it would never be smaller than or bigger than this number, because it would either, if it was smaller than this number, it would just wrap back around to be positive, be less than this value and right back in range. And if it was bigger than this value, it'd wrap back around to the min value. So it would never be outside of these ranges if this was an integer. But because we have a long, we can actually check this. And that's commented right here. So if it's within the bounds of an integer, set value to k. So this is value, you really want to set k. It should be the other way around. So we want to set k equal to the integer representation of value. So because value is a long and k is an integer, as defined right there, this is going to be a narrowing conversion. We're going from a big data type to a small data type, which means we have to explicitly cast the large data type to the smaller data type. So that's why we're putting int right here. And this is okay. This is normally your compiler. If you did not have this int right there, this would throw you a warning, something about an implicit cast, maybe implicit narrowing conversion, something along those lines. But that's okay. We would be losing information. But we've already checked to verify that the value is within the bounds of an integer, so it's totally fine for us to cast value to an integer. If we had a value that was larger than an integer in value, then this would not be okay. We'd be losing some information by casting this from a long to an integer. But again, because we've already verified that it's within these proper bounds, just like with that if statement right there, then we can safely say casting this to an integer will not lose any information, and we can go ahead and do that. If it is outside of these bounds, so if it's smaller than the min value or bigger than the max value, then we can just set k equal to 0. Normally, maybe you'd want to throw some exception or give some warning, because as far as your program is concerned, 0 is a valid small integer, but this is a little simpler. It doesn't throw any exceptions, doesn't throw any errors. Okay, we have a couple methods here. This one just gets k. Now moving on to the first one that you would actually have to program in yourself. The add method is going to take the current instance of small int, and then it's going to have a second instance of small int passed in as an argument. So looking back at the main GUI, we see an example of this. So we have s1 dot add s2. So this is calling the add method on s1 and passing in s2 as an argument. We want to add in the value of the s2. So this is the second small integer here, or here it's named sint. We want to add the value of sint with the value of this. So remember, this is a keyword referencing the current instance of the class. And in this case, we're talking about s1 because we say s1 dot add. When I say this inside the add method, I'm talking about s1 in this case. So I'm adding s1 to the value of s2, and then I'm storing the result as a long. Next thing you want to do is check if it's outside the bounds. If it is, then you want to return 0. If it's not, then you want to return the summation of these two values. A really important thing to note about the summation is so if we look at get value, we see get value returns an integer. So if let's say, for example, that I have a small int that is integer the max value, so it's the max integer value. Let's say sint is the max integer value, and I want to add 1 to it. So like, let's say this would be, or so this was s1, this was s2, I think. Let's say this was 1. This .get value is equal to 1, and sint.get value is equal to integer max. That's trying to add 1 to the integer max. And because this get value returns an integer, as I mentioned before, it can't possibly hold a number that's larger than the max value. So when I add 1 to this one, it's going to wrap back around to negative. And then if I check if it's bigger than the max value or less than the min value, it never will be, because it will either wrap back around over and go negative or wrap back around under and go positive again. So these two things will never be, if I add these together as integers as they are, they will never be outside the bounds, even if I set them equal to a long. So even if I was to do something along these lines, so I have long, something like this. So here I have the value of S1, the value of S2. No, it's the other way around. And then the sum, I'm setting the equal to the summation of these two. Because these are both integers, your computer is going to look at this and say, okay, so they're both integers. You want the result to be an integer. So it's going to do an integer addition here. This is going to be, it's going to be working with integers here. And then you just set it equal to a long. So this is setting a long equal to an integer. So as I mentioned, even if we specify long here, so even if we specify I want a long as the result, the addition is still going to be with integers. So this will still, even if this is a long, this will still never be larger than the integer max or smaller than the integer min. What we have to do here is we need to specify to our computer that I want you to do long addition here. And all we have to do there is cast one of them to a long, one or both, that's fine. So here I cast, this is the value of S1. Here I cast this one to a long. So now your computer looks at this and says, okay, I have an integer and I have a long. It's going to do long addition. So now if this was integer max and this was, I guess I switched that. If this was integer max and this was 1, then because this one, the 1 is cast to a long, your computer is going to do long addition here, and this will go past the integer max value, despite these both being integers. So now your computer is going to return a long from this. This is going to be equal to a long, and then we set the value of sum equal to that. Then we can do that same if statement that we would have had up here, checking if sum is less than the min value or greater than the max value. Now, obviously, if I were to change this to an int, that ruins the whole thing. This is so make sure that you have the result as a long, and make sure you're casting one of these values as a long. Okay, that's it. So you get the sum. You would want to return the sum right here. Well, assuming that sum was within the bounds of the max and min value, I would want to return sum here, but I can't just return sum because this is, again, an implicit narrowing conversion. Oh, there's the arrow. Cannot convert from long to int because long is a larger data type than what's being returned. What's being returned is an int. By just returning sum, I'm trying to return a larger value. So it would implicitly narrow or make the data type smaller. So it would lose information. And your computer doesn't want to lose information, but you have to tell it, I'm okay with losing this information by explicitly casting sum to an integer. So you'd have to do the same thing for the other ones. Oh, looks like there's even a helpful check if in bounds function at the bottom here. So you'll be wanting to use that in your if statements up here and in each one of these methods. Once you get that done, like I said, move back to main GUI launcher, copy paste these 2 lines until you get some test cases. And then you'll want to actually set the values of S1 and S2 in both of these little if statements right here. The code's pretty well commented, so it shouldn't be too hard. I recommend taking a little bit of time, sitting with it, read through it, make sure you understand it. Look through the code here, see what is being done with the inputs, that kind of thing. But otherwise, it's not too bad. All right, guys, best of luck with that.